Okay, so we've been talking about u substitution, and here is the general complicated looking form that it takes. And I want to do some more examples. So the second example will be integral of e to the minus 3x dx. So I want you to think about how this is a composition of two functions. So the two functions are going to be the exponential, base e exponential function, and the function which takes x to minus 3x. So what we're going to do is we're going to choose a new variable u, and we're going to let u be the inner function, minus 3x. And now we're going to try to change this integral from being in terms of x to being in terms of u. And there's a correction term that needs to be brought in, which will be accounted for using the differential, corresponding differential. So du would be minus 3, which is the derivative of this expression, times dx. And now we want to see if we can replace all the x's and dx's with u's and du's. So let's see what we get. We're going to get e to the u. We can replace the exponent with u, and we can replace dx. We can sort of solve this equation in some cases for dx. And if we divide through by negative 3, we'll find the dx is negative 1/3 du. And then we want to do this integral, which is now an integral of a function only of u. We can pull the negative 1/3 out in front of the integral to get the negative 1/3 times the integral of e to the u du. And the antiderivative will be just e to the u. And then we'll have a constant of integration, which is really going to be the constant of integration times negative 1/3, I guess. But so we end up getting negative 1/3 e to the u plus c. And that is the answer to this problem. But we want to find the answer to this problem. And we get that by, we replace all the u's with x's using our rule for what u is in terms of x. And so now we replace all the u's with minus 3x. Find that the answer is going to be minus 1/3 e to the negative 3x plus c. If we differentiate this, then the minus 3 will, let's see, so basically we'll have to use the our rule for the derivative of the general exponential rule, I guess we called it. And it says that we keep e to the, or if we want to differentiate functions of the form e to a function, we keep that the same, and then we have to multiply it by the derivative of the exponent. The derivative of the exponent in this case will just be minus 3, which will cancel with this coefficient so that we just get e to the minus 3x. So that is in fact the right answer. So now I want to do a problem which seems more complicated than the ones we've been doing. Let's try to integrate 1 over x times the natural log of x. So in this problem, it's not as clear how there's a composition of functions, or how we should break things up into pieces. How we'll have a composition, and what piece will be the derivative of the inside function. What we're going to do first is I'm just going to rewrite this as the product of 1 over x and 1 over the natural log of x. And then let's stare at that for a bit. So in the first piece, in the 1 over x, we don't really have a composition of functions. So applying u substitution to that, we're trying to, won't really get us anywhere. However, in the second part of the integrand, 1 over the natural log of x, that is a composition of two functions. The inner function is going to be the natural log of x, and the outer function is going to be 1 over whatever, that function. And notice that the derivative of the inner function, the derivative of the natural log function, remember, is 1 over x. So in fact we have a situation where we have a composition of functions and the rest of the integrand is accounted for by the derivative of the inner function. So that's exactly what we want. So we're going to do a u substitution, and we're going to let u be the inner function that I was talking about. So u will be the natural log of x. And now d